the neural basis of Parkinson's disease and dopamine loss, where the problem begins in the brain. Parkinson's disease does not start in the muscles. It starts deep in the brain in a region called the substantia nigra. This area contains neurons that produce dopamine, a neurotransmitter involved in movement control. At first, nothing feels different. Changes begin at a cellular level long before noticeable symptoms appear. Why dopamine matters for movement? Dopamine plays a key role in coordinating smooth and controlled movement. It is part of a larger system called the basal ganglia, which helps regulate movement initiation. Without enough dopamine, this system does not function properly. Movements become slower, less precise, and harder to control. The progressive loss of dopamine neurons. Dopamine-producing neurons gradually degenerate. This loss is not sudden. It happens over time. By the time symptoms appear, many neurons have already been lost. This is interesting because it means the disease is already advanced before it becomes obvious. Step 1. Disruption in the basal ganglia circuit. The basal ganglia operate through a balance of signals. Dopamine helps maintain this balance. When dopamine levels decrease, inhibitory signals become stronger. This makes it harder for the brain to initiate movement. Step 2. Reduced activation of motor pathways. With less dopamine, pathways that support movement become less active. The brain still sends signals to move, but those signals are weaker or delayed. This leads to symptoms such as bradykinesia, which is the slowing of movement. Step 3. Increased muscle rigidity and tremor. As the imbalance continues, muscles receive inconsistent signals. This results in rigidity and, in many cases, tremors. The tremor often appears at rest. It decreases during intentional movement. This pattern reflects how the underlying neural circuits are affected. Why symptoms develop gradually? The brain can compensate for dopamine loss up to a certain point. Other pathways adjust to maintain function. But as more neurons are lost, compensation becomes less effective. This is when symptoms begin to appear and progressively worsen. How treatment targets dopamine. Many treatments for Parkinson's focus on restoring dopamine levels or mimicking its effects. Medications like levodopa are converted into dopamine in the brain. This helps improve movement. But it does not stop the underlying neuron loss. It manages symptoms rather than curing the disease. What this means for understanding the disease. Parkinson's disease shows how a specific neurotransmitter affects an entire system. The loss of dopamine does not just change one function. It disrupts a network that controls movement, coordination, and timing. This makes the effects noticeable at the level of behavior. Final thoughts. The neural basis of Parkinson's disease comes down to the gradual loss of dopamine-producing neurons and the imbalance it creates in movement pathways. What starts as a small change at the cellular level eventually affects how the body moves. And once you understand that connection, it becomes clear why the symptoms develop the way they do. Thanks for watching.